All right, guys, it's been a while since we've done one of these, but we're going to go back over the review for the area and perimeter test. But honestly, it's mostly area. Number one, find the area of the following. Break this up into two shapes you know. 4 times 8 for the rectangle on the bottom, 32. On the top, you know that that's going to be 8 across. But if you drop a line down to find the height, you can break this into two small right triangles. And if you do that, then you can do Pythagorean theorem, because you know that's going to be, let's see, that's going to be 4 and 4 because the 8 got cut in half. So if you know your Pythagorean triples, it's 3, 4, 5. But even if you don't, a squared plus 4 squared equals 5 squared. 25 minus 16 is 9. Square root that, a equals 3. So 1/2 times base of 8, don't forget that whole bottom is 8, times height of 3, which is 12. So 12 plus the 32 you got for the rectangle, 44. All right, number 2, circle C with the diameter of DG is shown in the figure below. To the nearest hundredth of a centimeter, what is the area of the sector? You will have all the formulas for tomorrow. Area of a sector formula is x over 360 times the area of a circle, which is pi r squared. X is the arc degree, so whatever the arc of that sector is, you need it in degrees. And r, of course, is our radius. So if this is a right angle here, and we know a diameter is 180, then 20 from 90, or 90 minus 20, is going to find us the angle of that. And remember, central angles in the arc are the same. So x is 70. Change colors here. And the radius, of course, you see is 8. So then you just plug in the formula, 70 over 360 times pi times 8 squared. Put that into your calculator, and you should get to the hundredths place, 39.10. And that is centimeters squared. Number 3, find the area of triangle RST. So there's two things to look, or two ways to approach this. As a big triangle itself, you have a 45, 45, 90, which is x, x, x square root of 2. So as a triangle, 8 would be the base. You would have to find a height. However, if you draw that line, you've also broken this down into two smaller right triangles, and they're still individually 45, 45, 90. Now, what's different about that, or why that will give you the height a little bit easier, is that on the smaller triangle now, that becomes x, x, x squared to 2, and you already know that that's going to give you 4, because the 8 will get cut in half. Well, if that's 4, that's 4, and so that is the height. So the height is 4, the base at the bottom is 8, you have everything you need. 1/2 times base times height, and that is 16. Number 4, that is a rhombus. 12 and 12, 15 and 15. Remember rhombus formula, D1 times D2, and then take the half or multiply 1/2 times that. So 1/2 times 24 times 30 should give you 360. And on some of these problems, they didn't give you units. So you can put unit squared, you can just write the u squared. But it's a good idea, even if it's not given to you in the problem, to identify it in some way so you know. Number 5, in a question like this, some people had questions about, it says, which of the following is closest to the area in square inches of the hexagon if D is measured as 24 inches? And I know the D is kind of located up top, so it looks like the 24 might just be the half. The intention of the problem, or my intention with it, was that that's like a diagonal, so the whole thing is 24. On the test, if there's a problem similar, I will make clear what it is. So for us, the halves here, or it gets cut into 12 and 12. So this is a hexagon. We're doing regular polygons like we did Tuesday and Wednesday. You need apothem and perimeter. Remember that we set up a right triangle here that's at 30, 60, 90. So if the hypotenuse is 2x and that x was a 12, or I'm sorry, the hypotenuse is 12, the x at the bottom will be half of that, which is 6. So as far as the side lengths go, a full side length would of course be 12, and 12 times 6 is 72. That's your perimeter. Sorry, 72. And then more importantly, or maybe just as importantly, if for the apothem, the formula for that side is x square root of 3, and if the x is 6, then our apothem is 6 square root of 3, and then you just multiply that out. 1/2 times apothem times perimeter, which is 374.1. Again, no units given. Number 6, what is the area of the trapezoid? Isosceles trapezoid. Isosceles trapezoid, base 1, base 2. But it's not just the 15, it's this whole thing, so the base 2 has to be 20. Now at the moment the height's missing, but again, I know this picture's not drawn well, I guess, but the 45 they're telling you is right there. So this is a 45, 45, 90 right triangle, meaning x, x, x square root of 2. And if this side is 5, that side is 5, just like on that previous problem. There's nothing to solve, per se. So there's your height. So the area formula is 1/2 times parentheses base 1 plus base 2 times the height. And that's going to give you 75. Last one on this page, a square is inscribed in a circle whose radius is 7 inches. What is the area of the square? So the easiest way to approach this is to remember that a square is a rhombus, and therefore you can use the area formula for a rhombus here, much like we did on the previous problem on this page. 1/2 d1 times d2. So it tells you the radius is 7, which means all the way across would be 14. And because it's a square, both diagonals would be congruent. So each one is 14. Then it's a simple 1/2 times 14 times 14, which is 98. And this one was labeled in inches. All right, so that's the first page. Hope that helped. Check for the second page on the next video.